Hi students, welcome to the video lecture on numerical problems with superposition theorem. Now here this is a problem on superposition theorem. Here what is the problem? Here apply superposition theorem to find V0 in the circuit shown in the figure below. So this is the circuit they given, and here they are asking the V0. So here the response they are asking is V0 means here the voltage drop across 1 ohm resistance. This is a multi-source circuit. Here two sources are there. One is a 6 amperes current source and one more 18 volts voltage source. So that's why here you can easily apply the superposition theorem. So coming to the statement of the superposition theorem, the response in any element in a linear circuit is equal to the algebraic sum of the responses caused due to each independent source acting alone. So that's why here how many cases we are going to discuss means two cases. What are they? Each case for each source. So that's why first of all case 1. So what is the case 1? Here the case 1 is case 1 when 6 amperes current source is acting alone. Now redraw the circuit with the 6 amperes current source alone, and replace this voltage source with short circuit. That is its internal resistance. That internal resistance is not given, so that's why you replace here with a short circuit. So that's why here this is a circuit. I am redrawing the same circuit but with only current source. With only current source. Okay, here this is a voltage source. This voltage source here I am replacing with short circuit. There, that is the way. Now remaining elements I am representing 6 amperes and this 2 ohms, and here it is 2 ohms, and this is 1 ohm, and this is a 4 ohms. Now here where is asking their response? They are asking their response here. This is the V1. V1 means I am considering this is the first response due to the 6 amperes current. So that's why I am considering V1. Now how to apply? You can apply either mesh analysis or nodal analysis or any other KVL, KCL, whatever it may be. But you got the response. You need to determine the response across the 1 ohm resistance. Okay, next. Now here by seeing the circuit itself you can easily identify this 2 ohm and this 2 ohm are in parallel. So that's why. So what do you apply this one? Two resistance are in parallel means you can apply reduce this two resistances into a single resistance. So that's why here how to apply? Here 2 and 2 ohms and 2 ohms are in parallel. So that's why replace with this one. Here R dash equal to 2 into 2 divided by 2 plus 2. R1 into R2 divided by R1 plus R2. 4 divided by 4 equal to 1 ohm. So that's why I redraw the circuit once again. Okay. A single resistance, and here one more resistance, here one more resistance. Now this is your 1 ohm and this is your 1 ohm and here 4 ohms. Now this 1 ohm, this 6 amperes current source. Now this 1 ohm and this 1 ohm are in series. So that's why 1 ohm and 1 ohm are in series. So that's why what you are going to do now. So this is your current source. Okay, now here 1 ohm and 1 ohm are in series means here the R dash equal to 1 plus 1 equal to 2 ohms. You must add this when two resistance are in series. We already known. So that's why this is a 2 ohms and here it is a 4 ohms. Okay, now this is your 6 amperes current. Now here you can apply the current division rule. Now apply the current division rule. According to the current division rule. So what is the current division rule? Here two resistors are there. We know what is the total current. So that's why what is the current? We need the response here. So that's why we need to find out what is the current here it is entering. So that's why where this 1 ohm in this 2 ohms resistor. So that's why now I need to find out what is the current here. So what is the current here? I will consider this as a I1. So what is this I1 value? I1 value equal to 2 resistors are in parallel. So that's why what is the total current? Total current is 6 ohms, 6 amperes into, okay, in the numerator you are going to draw the, you are going to write the who is opposite for this 2 ohms. This is 4 ohm. Is it right or not? Here I need to find out I1 value. So who is opposite for this 2 ohms? So that's why in the numerator 4, okay, and in the denominator you have to add these two resistance, 2 plus 4. So that's why 6 into 4 by 4. So how much? Sorry, 6 into 4 by 6. This 6 and this 6 get cancelled. Now you got 4 amperes. So 4 amperes is the current in the 2 ohm. So the same 4 amperes here it is passing. This 4 amperes. And the remaining 2 amperes is passing through the 4 ohm. So we no need to find out. Here they are asking the response here. So the same 4 amperes is entering it into this 1 ohm resistance. So that's why here what is the voltage drop? So what is the voltage drop? So the V1 value is how much? What is the voltage drop formula? I into R. So that's why 4 ohms, 4 amperes into resistance value is 1 ohm. So that's why I into R, 4 volts. So this is the response due to the only 6 amperes current source. Clear? Now we are going to discuss about the case 2. What is the case 2? In the case 2, only 18 volts voltage source is acting alone. At that time, this current source is replaced with the open circuit. Okay. Now, so what is the second case? Case 2. Case 2, when 18 volts voltage source, 18 volts voltage source is acting alone. So again redraw the circuit with only 18 volts, with only 18 volts source. So this is your 2 ohms and this is the 2 ohms and here is your 1 ohm where they are asking the response, and this is your 4 ohms and this is your 18 volts. Okay, now this is the 18 volts and this is 2 and this is 2 and this is your 1, and here the current source is there. Now what I am asking, here only 18 volts is there. So that's why what I have to do here I can make it as a open circuit. Actually this is the current source place in the original circuit, so that's why I replace here. I am considering only 18 volts. Now what is this resistance? I think that resistance is 4 ohms. Okay, this is a 4 ohms. Okay, now I need to find out again the response in the same 1 ohm resistance due to this 18 volts. I consider this as a V2. So how to find here? Again here this 2 and this 2 are in parallel, so I am going to reduce this one. 2 ohms and 2 ohms are in parallel. So that's why what is your R dash? What is the formula? R1 into R2, 2 into 2 divided by R1 plus R2. So that's why 4 divided by 4 equal to 1 ohm. So now I can replace here this with a single resistance, and here is your 1 ohm resistor, and this is your 4 ohm, and here 18 volt source is there, 18 volt source. Okay, so now your response is V2 here. So there is no need to draw this one. Here is the open circuit, so that's why. Now I can easily apply. It is a single mesh. It's a single mesh. So I need to find out the voltage drop across the 1 ohm resistance. So I can easily apply the KVL. So what is the KVL here? So here wherever the voltage source is there, here the current is coming from here. Okay, or you can easily apply the mesh analysis. In any way you can follow. Here I can apply the KVL. Okay, so that's why I is the current coming from here. So that's why. So how to apply this one? Here is a single mesh, so that's why. So the algebraic sum of the voltages in a closed path is 0, so that's why that is a KVL. So 4 into I, current into resistance, this is the voltage drop, and here the same current is entering in the 1 ohm, so that's why I into 1, so that is I. Next this is also I into 1, so that's why I. Okay, is next again it is entering into the minus 18, so that's why minus 18 equal to 0. So what happened here? 6I minus 18 equal to 0. I equal to 18 divided by 6, that is 3 amperes. Okay, so now this is I value is 3 amperes. So what happened to your response here? V2. So what is a V2? V2 means voltage drop across the 1 ohm. So that's why voltage drop formula is current into resistance. So that's why 3 into 1. So which you have 3 volts. And now this is the response only due to the 18 volt source. So now what is the total response when two sources are acting simultaneously? So now the total response V is equal to V1 plus V2. So what is the V1 value? What is the V1 value? 4 volts. 4 plus, what is the second response? 3. So that's why 4 plus 3, 7 volts. Okay. So this is about the total response we find out using the superposition theorem. Okay, thank you.